I'm Kiran Kumar from Nature of Physics. Today topic is collision, elastic and inelastic collision, one-dimensional elastic collision, final velocities of first body and second body. Clearly step by step I will explain. Please watch full video, you will get clarity student, and please do like and subscribe, comment our channel Nature of Physics. See, a strong interaction between bodies in which exchange of momenta takes place is called momentum. And elastic collision, the collision in which both momentum and kinetic energy are conservative, is called elastic collision. So before the collision momentum is equal, after the collision momentum, that is taken as law of conservation of linear momentum. And before the collision kinetic energy is equal, after the collision kinetic energy, that is taken as law of conservation of kinetic energy, that is initial kinetic energy is equal final kinetic energy. Next, inelastic collision, the collision in which only momentum is conservative but kinetic energy is not conservative, is called inelastic collision. The example for the inelastic collision is cricket bat and ball collision, student. And elastic collision, the collision between the nuclei and fundamental particles, that is nuclei and alpha particle in Rutherford alpha particle scattering. Next one is one dimension elastic collision. So the velocities of the bodies involving in collision are along the same straight line is called one dimension elastic collision, student. So the before the collision and after the collision, the initial velocities and final velocities along the same straight line, then such a collision is also called one dimensional elastic collision. Considering two smooth spheres moving along the straight line, student, of masses m1 and m2, before the collision its initial velocity u1 and u2, and after the collision final velocities v1 and v2 respectively. Before the collision momentum is m1 u1 of first body and second body m2 u2, and after the collision first body momentum is m1 v1 and second body momentum is m2 v2. So before the collision momentum is equal to after the collision momentum is law of conservation of linear momentum. And before the collision kinetic energy is equal to after the collision kinetic energy, that obey the law of conservation of kinetic energy. Step by step we will discuss the derivation, student. First one, law of conservation of linear momentum, that is initial momentum is equal to final momentum. Okay, student, initial momentum is here m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So m1 masses LHS side and m2 masses RHS side. So that m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2, student. And next step, m1 common LHS side, that is u1 minus v1 is equal to RHS side m2 common, that is v2 minus u2. Now it is taken as equation number 1. This is law of conservation of linear momentum derivation. Before the collision momentum is equal to after the collision momentum. Okay, student. And continuation, law of conservation of kinetic energy, that is before the collision kinetic energy is equal to after the collision kinetic energy, student. So that continuation derivation here of m1 u1 square plus of m2 u2 square is equal to of m1 v1 square plus of m2 v2 square, student. Before the collision kinetic energy of two bodies is equal to after the collision kinetic energies of the two bodies, but addition is there, see, student. And continuation, same m1 mass LHS side and m2 mass is RHS side. Then the continuation equation of m1 u1 square minus of m1 v1 square is equal to of m2 v2 square minus of m2 u2 square, student. Okay, LHS side of m1 common, that is u1 square minus v1 square, and RHS side of m2, that is v2 square minus u2 square. Okay, student. and there is a formula we can write, that is if a square minus b square is equal to a plus b into a minus b. This formula is applied for this concept, so that then the continuation equation is, here half is get cancelled student, so that m1 of u1 plus v1 u1 minus v1 is equal to m2 of v2 minus u2, next v2 plus u2 student. See there, and I can write this is equation number 2 student. Okay, now equation 2 divided by equation 2 divided by equation 1 student. Okay, and the continuation derivation, now I'm going to write m1 is, this is second equation, m1 u1 plus v1 and u1 minus v1 is equal to m2 of v2 minus u2 v2 plus u2 student, and LHS side divided by first equation m1 of u1 minus v1, RHS side is m2 of v2 minus u2. See student, here this m1 get cancelled, m2 get cancelled, u1 minus v1 and v2 minus u2 get cancelled, so I'm getting here u1 plus v1 which is equal to v2 plus u2. Now I am considering this is equation A for better understanding using this equation student, and continuation next step equation, rearranging this is u2 LHS side and v1 RHS side, the resultant equation u1 minus u2 which is equal to v2 minus v1. This is I can write as equation number 3 student. Okay, so this is writing like this. Okay, so relative velocity of approaching before the collision is equal to relative velocity of separation after the collision student. Okay, so that I can write relative velocity of approaching before collision is equal to relative velocity of separation after the collision student. Okay, so u1 minus u2 is relative velocity of approaching before the collision, and v2 minus v1 represent relative velocity of separation after the collision, and there is a condition student. Okay, the condition is writing here specially, that is u1 greater than 2 u2 and m1 greater than 2 m2 taken. u1 greater than 2 u2, then only the collision is takes place between m1 and m2, and we are considering m1 greater than 2. Final velocity student. Okay, of m1 mass is v1 and m2 mass is v2 student, so that using the basic equation from equation number A, that is u1 plus v1 is equal to v2 plus u2, but we need the value is v1 we have to find. From this equation I am writing u1 plus v1 minus u2 which is equal to v2. This is equation number B student. Okay, and next step here, equation number B in equation number 1 student, and the continuation derivation is here. See there, so m1 of u1 minus v1 which is equal, second equation, sorry, first equation student, m2 of v2 value is equal to u1 plus V1 minus U2 into minus U2. Okay student, see student, once again M1 of U1 minus V1 is equal to M2 of U1 plus V1 minus U2 minus U2 student. So the replaced value is this, student. Okay, so and continuation step is here, M1 of U1 minus V1 which is equal to M2 of U1 plus V1 minus 2 U2 student. Now M1 is multiplied M1 U1, M1 V1 LHS side and RHS side M2 U1 plus M2 V1 minus M2 2U2 student. And here we need to find the value V1 RHS side positive, LHS side negative, so that remaining values M2 U1 from RHS side to LHS side and 2 M2 U2 also from RHS side to LHS side, so that we will get here M1 U1 M2 U1 plus 2 M2 U2 is equal to M2 V1 plus M1 minus M2 of U1 plus 2 M2 U2 is equal to M1 plus M2 of V1 student. RHS side V1 common and LHS side U1 common. This value from RHS side to LHS side, so that M1 minus M2 of U1 plus 2 M2 U2 whole divided by M1 plus M2 is equal to V1 student. And the final equation is here V1 which is equal to M1 minus M2 by M1 plus M2 of U1 plus 2 M2 U2 divided by M1 plus M2. This is I can write as equation number 4 student, final velocity for the M1 mass. And similarly we can do for the M2 final velocity using same method. From equation number A is U1 plus V1 is equal to V2 plus U2, and we wanted to find the V2, so that I am writing here V1 is equal to V2 plus U2 minus U1. This is I can write as equation number C student. This is I can write as equation number C. And then continuation equation C in equation number 1 student, so that the derivation is continuation M1 of U1 minus V1 value is V2 plus U2 minus U1 is equal to M2 of V2 minus U2 students. And next minus is multiplied M1 of U1 minus V2 minus U2 plus U1 is equal to M2 of V2 minus U2. See student, M1 of U1 and U1 2 U1 addition minus V2 minus U2 which is equal to M2 of V2 minus U2. Now M1 is multiplied LHS side, 2 M1 U1 minus M1 V2 minus M1 U2 which is equal to M2 V2 minus M2 U2 student. One thing notice student here, V2 RHS side positive, LHS side negative. Rearranging the equation like this, get continuation step is 2 M1 U1 and this become plus M2 U2 minus m1 u2 this step here, and m2 v2 as usually writing this value from LHS side to RHS side become positive m1 v2 student, and LHS side u2 common and RHS side is v2 common. So 2m1 u1 plus m2 minus m1 of u2 which is equal to m1 plus m2 of v2 student. And next step, this m1 plus m2 from RHS side to LHS side, 2m1 u1 plus m2 minus m1 of u2 divided by m1 plus m2 which is equal to v2. And now final step is, that is v2 which is equal to 2m1 u1 divided by m1 plus m2, and this value is m2 minus m1 divided by m1 plus m2 of u2. This I can write as equation. Please do like and subscribe our channel Nature of